I wanted to do a quick overview of lessons for this week. So, we were talking about expressions and specifically equivalent expressions. So, first, we reviewed what we had previously talked about as far as expressions are concerned toward the beginning of the year. The first thing that we ever did with expressions was to figure out the parts of an expression. So once we knew that expressions were this combination of numbers and letters and symbols that express a mathematical sentence, then we learned these parts. So we have variables, coefficients, constants, terms, and factors. And variables are your unknowns, typically represented with a letter. Coefficients are multiplied times a variable. So they sit next to a variable. Constants, they do not have variables. Terms are the parts of the expression being multiplied. And they are separated by addition and subtraction. Factors are the specific pieces that are being multiplied. So we're going to go through the first two together, and then after that, I want you to try the last three on your own on a piece of paper, and then if you have questions, of course, ask. All right? So variables are unknowns. We represent them with letters. So for this first expression, y is a variable. Coefficients are what is multiplied times the variable. If there is a number sitting next to the variable, then that's being multiplied times the variable. So we have a coefficient of 2. Constants contain no variable. Well, the part of the expression that contains no variable is this little distributive property here, 3 times 5 minus 2. Then we look at our terms. Well, terms are the parts that are being multiplied. So in this particular expression, I'm going to change the sizing here so that it will be small enough for me to type what I need to type in it. Okay. Term 1 is 2y. 2 is being multiplied by y. And then we have a plus sign. So that plus sign is our separation between the first term and the second term. So term 2 is going to be 3 times 5 minus 2. Now, the reason why that is a term to itself is because this 3 is being multiplied by the 5 minus 2. Now, if you wanted to, you could go ahead and simplify this expression before you start identifying variables, coefficients, constants, terms, and factors. However, at this point in the year, we had not discussed how to simplify an expression yet. So in this case, you would need to know that this is a term because it is actually a product. It's the product of 3 and the difference. All right. So that brings us to factors. And same thing, I need to change the sizing here so that I have room to type the information that you will need. So for term 1, 2 is being multiplied by y. So those are our factors in term 1. Term 2, 3 is being multiplied by the difference of 5 and 2. So those are our parts for the first expression. The next expression, we do see a variable. We see x. That x has a coefficient of 4. There is a constant as well. And again, these are the pieces that do not contain variables. And then we have our terms. This expression is also one with two terms. So the first term is 11 times 3 minus 4. And it's the same thing there for that. It's a term because it's actually the product of 11 and the difference. Then we have term 2, and in term 2, we have 4x because 4 is being multiplied by x. And with our factors, we look at the pieces that are being multiplied and actually separate them out. So we have 11 being multiplied by 3 minus 4. Then in term 2, we have 4 being multiplied by x. So I want you guys to try, if you're working from home, the next 3 on a piece of paper on your own. And if you have questions, just let me know. And these are your notes. So they will go in your math folder for you to keep, for you to reference back to. So they are yours to complete. The next thing that we talked about when we were talking about expressions toward the beginning of the year is how to take these mathematical sentences and even word problems, but at first just mathematical sentences, and create an expression from them. And this is really a review of what you have done in 5th grade with taking a mathematical sentence and then creating that expression. So the first one says 9 less than a number. Now, most of us would want to go 9 minus x. However, this is saying you have a number, an unknown number, and remember that can be any variable that you want it to be, and 9 less than that number. So it's actually your unknown minus 9. The next one says the product of a number and 8. So product is multiplication. So we're taking an unknown number and multiplying it times 8. And again, most of us would want to say, okay, my unknown times 8. But at this point, we don't want to write it in that way. At this point, we want to already know that when we have a number being multiplied by a variable, that we want to instead go ahead and place those two next to each other. I'm going to go over one more of these with you, and then you'll do the next 2 on a piece of paper. And again, if you have questions, please message me or ask when you return to school. 4 minus the product of 6 and a number. So 4 minus a subtraction, and we're subtracting the product. And it's the product of 6 and a number. So again, that's a number being multiplied by an unknown. So we would write it like this, and you don't have to include the parentheses on that one. So try the next 2 on your own. All right, so now that we've reviewed that one, the next thing that we talked about with expressions is how to evaluate an expression. So when we evaluate an expression, if it contains a variable, you would need to know what to substitute in for those values. So these are all practice with that. So with this first one, we have 3x plus 4y in parentheses. Now, before we actually start working with that, we've got to substitute these values of x and y before we do this. So 3 is being multiplied times that x value of 3 plus 4 times that value for y, which would be 2. And then we keep that parentheses around with the 2 outside of it. And then we just follow order of operations from here. So order of operations says that I have to begin in my parentheses, my grouping symbols. And then within that grouping symbol, I have multiple operations. So then I would follow order of operations from there as well. So it's like having an expression within an expression. So we have 3 times 3, which is 9, plus 4 times 2, which is 8. And then we bring down what we have left over. So we have 9 plus 8. 9 plus 8 would be 17. And then we are going to multiply that times 2. And we should get 34. So that is how I would solve these particular expressions, how I would evaluate them. Sometimes you'll hear simplified used. The next one I am going to go over with you because in class, many had forgotten that when it's written as a fraction like this one, that you would see it like this, okay? And then you substitute the x values. So we have 4, and then 6 minus 4 is the x value. So 6 minus 4 is 2. So we have 4 halves. Well, fractions are division, so we can divide this. And 4 divided by 2 would be equal to 2. So just a quick reminder there of what that fraction symbol is for. Remember, fractions are division. I want you to try the last one there on your own, on your piece of paper that you're working on, and just let me know if you have any questions. Now, what we've talked about this week, the new things we've talked about, is equivalent expressions. So before we left for winter break, we started talking about distributive property and how to create equivalent expressions using distributive property, which is what this is. And so we have a 9 being multiplied by this sum. Well, when you have that, this is distributive property. Sometimes you'll see addition here, sometimes you'll see subtraction. But you can take this 9 and distribute it by multiplying it times the 4 and then times the 7 and leaving that addition symbol in between. So if I did 9 times 4, that would be 36, plus 9 times 7. Well, 9 times 7 is 63. So now I have an expression that is equivalent to that. And we talked about that again before winter break started. And then in my next one, I'm starting off with the sum of two numbers, and I can then take this and create distributive property with it. So they're both distributive property. It's just one is starting with distributive property to get two numbers that you're adding together. This is two numbers added together that we're going to turn into distributive property. And we can do that because they share a factor. These both contain zeros at the end, which means that 10 would be a common factor for those. Since 10 is a common factor, then we look at our numbers and we say, okay, 10 times what would be 20? Well, 10 times 2. And we say 10 times what would be 90? 10 times 9. Now we have created an expression that is equivalent to this first one. Then we have the same thing, but we've included a variable. All right. And before I talk to you about those two, I want to first go over this chart. This is a chart that you want to write down, that you want to have in your math notes to refer back to, especially since we will be moving into equations. So it's extremely important for you to know that when you have terms in an expression, anytime you have terms that are the same, you can combine them together. Well, what qualifies as a like term? Well, they either have to have the same variable or they have to both not have a variable, unless it is multiplication or division. So, in this first example, 2x plus 8x. Well, those two terms are both x. So you can take the 2 and the 8 and add it together. 2 plus 8 is 10, so that's 10x. So yes, we can combine those. Those are like terms. Then looking at the next one, 2x plus 8. Well, there's two terms. 2 has an x, but 8 does not have an x. So those cannot be combined. Those are not like terms. Then we have 2x plus 8y. They both have variables, but the variables are not the same variable. So those are not like terms. We cannot combine those. In the next example, we have 2x times 8. In this, we can. We can go ahead and multiply 2 times 8. Well, 2 times 8 is 16, and that's 16x. And the reason behind that is your order of operations. Terms are separated by addition and subtraction, but this is multiplication, and multiplication comes before addition and subtraction. And then you have commutative property that says it doesn't matter what order we multiply in. So since 2 is being multiplied by x, and then that's being multiplied by 8, it doesn't matter the order. So you can go ahead and multiply 2 times 8 and then leave that x next door so that when we have an x value, we're multiplying that as well. So just know that when you have multiplication like this, you can multiply. You multiply the two numbers and just remember to include the variable. So yes, you can combine that. And then in the last one, you have 8x minus 2. 8 has an x variable, 2 has an x variable. Those two terms share the same variable, so they can be combined. When we do this, we look at the symbol in front of this and we have a minus. So we have 8x minus 2x. That would be 6x. And I should have written that over here, 6x. So yes, those can be combined because they are like terms. So again, make sure that you have written this down on a piece of paper or something because this is extremely important. You have to know what you can combine together and what you can't. So now that we've covered that, let's go back and take a look at completing this chart. So we have 2 being multiplied by this sum. So we can distribute the 2 by multiplying it times the first term and then the second term. So in this one, 2 times 12x. Well, 2 times 12 is 24, and then we just need to remember to include that variable. So it's 24x. Plus 2 times 4 is 8. Do not forget to distribute that 2 to the last part here. That is often forgotten. All right, the next one is the sum of two terms, which is like what we have up here. And like with 20 and 90, 3 and 12 share a factor. They share a factor of 3. Well, 3 times what would give you 3? Any number times itself gives you that number, right? So it's 1. You can actually put 1y, or you can just leave the y by itself. Anytime you see a variable sitting there by itself, the 1 as a coefficient is implied. Then you have 12. Well, 3 times what gives you 12? 3 times 4, and don't forget to include your variable. So now we have created equivalent expressions for each of these examples. Again, this is something you need in your notes. And since you're working from home, you can just do that on a piece of paper. Okay. The last thing is looking at equivalent expressions and combining like terms as all one thing. So when we look at an expression, if we want to know if these expressions are equivalent, we first have to make sure that they are simplified. So 16x plus 8 minus 4y. Well, one term, two terms, three terms. None of these share a variable, and there's only one constant. So this expression is simplified as far as it can go. So let's take a look at the next one. We have 2 times 2x plus 4 plus 8x minus 4y. Now, you will see distributive property in your expressions. So please make sure that if you see distributive property, that you do that first and then combine any like terms. So in this particular expression, 2 times 2x would be 4x, plus 2 times 4 is 8. Remember, don't forget when you're distributing to distribute to both terms. Bring down everything else, plus 8x minus 4y. Now we have some terms that are the same. We have two terms that have x. Well, we have 4x, and then we have a plus 8x. 4 plus 8 is 12, and that's a 12x. And then we leave 8, and we leave the 4, minus 4y. Now we can look at this and we can say, okay, is this expression equivalent to this other expression over here? Not really, right? So anytime you want to determine if an expression is equivalent, you first have to simplify them. So we have distributive property in this next one. 4 times 4x is 16x, plus 4 times 2 is 8, minus 2 times 2 is 4y. So we have 16x plus 8 minus 4y. And we can see that, yes, that is equivalent because x has 16, there's a constant of a positive 8 there, and then they both have a minus 4y. So those two expressions are equivalent. Something else I want you to take note of, even if the expression was this, this is still equivalent to these other two. Even though it's not in the same order, it's still equivalent. All right, and then this is not equivalent. It has the same numbers, but instead of a minus 4, we have a plus 4. Instead of a plus 16, we have a minus. So this is not an equivalent expression. So just make sure that you remember those things when you are finding equivalent expressions. So that finishes up what we talked about as far as equivalent expressions. The only other thing I want to go over with you guys to review for what we talked about this week is the other two slide presentations. And I will do those in another video so that it's not so overwhelming. But this was the first thing that we did with equivalent expressions. We reviewed what we had already discussed with expressions and then had a preview of what was to come for this week. So rewind, pause the video as much as you need to. Make sure that you have these things down on a piece of paper to put in your math folder. make sure that you have labeled it as expressions. You could even label it as expressions review if you wanted to.